What's up my friends, welcome back to another weekly update video, and I really hope that you like these videos and that you will get to know me even better. And I hope that you liked the previous video from the last week. Anyway, let's see what we will see in today's week. First of all, I'll talk about the video that I'm recording right now for this weekend. Then I'll show you a video for the future, for 2 or 3 weeks from now, because this project will be very big and I'm using a lot of 3D printed parts, actually like 3 or 4 kilograms of 3D printed parts. This will be another 3D printed tank, so in a moment we will see that. Then I'll show you the new part that I have here on my workshop, and this will be a power supply from Keysight, which is a little bit expensive but is awesome. Then we'll have the Q&A, of course, so I will answer all your questions from my previous video. And then we'll have the theory part for this weekend. And by the way guys, remember that I will answer all the questions from this video in the video from the next week. So if you have any question for me, just post it below and I'll try to answer that in the next video. And remember that this last weekend I posted a new video and I show you how to build an entire escape room using Arduino, the problems that I have, and how to build an entire business using just Arduino and coding. So if you are interested into that, please go and watch that video if you haven't seen it yet. So guys, I hope that you like this video and you learn even more. So let's play the intro and let's get started. What's up my friends, welcome back. So let's start this video and talk about the projects that the video that I'm recording right now for this weekend. This weekend we'll have another series for vintage teardown, and I'll be opening this old TV. This is using old TV analog signal. So we will see what we have inside. I won't show you inside because that's the cool part about the vintage teardown, that you will see all the components. So just wait for the weekend to see the entire video. But I will tell you that we'll see the cathode tube. We'll see a very cool component, which is the flyback transformer. What more do we will see? Oh, we will see a filter, band pass filter, because this is using analog signal. So you have to just pass one frequency in order to select the channel. And all the components that we have inside, of course. We will test it. So this TV here wasn't mine, so I don't know much about it, but I do know that it works, but I don't have signal for it, because here in Spain we don't have analog TV anymore. We only have digital TV. So this doesn't work with digital TV, so I would need a receiver, which I don't have neither, a receiver with a video output, because we do have a video input on the back. But anyway, stay tuned for the video, because we will learn about how analog TV works, how the filter works in order to select the channel, how the flyback transformer works, and also the cathode tube and all the rest of the components, which are all very vintage. We only have capacitors, resistors, and maybe 1 or 2 ICs. So this weekend you will see the full video about the teardown of this vintage old TV. So another vintage teardown. So now let's talk about the future project, and that was the project with a lot of 3D printed parts. So let's talk about that. Oh guys, just one more thing about the video for this weekend. I've just finished recording that video and it took me the entire day because we had a lot of small screws and I wanted to get out all the components and record those. So you will see the full video this weekend. But anyway, I've just closed back the TV, but I took out this component and I just wanted to show this. And we will talk about this in the video for this weekend. Anyway, this is a flyback transformer and I took it out because I want to use this in a future project. And this is a quite powerful transformer. You could get up to thousands of volts and even create a plasma arc with this guy. So we'll see this in a future project. So I just wanted to show you this. Anyway, now we can get with the future update for a future project about the 3D printed tank. So let's go on with that. Okay guys, so here we are, another day of the week, another update. So as I told you, we'll talk about the future project that I'm working on. And that will be about this tank here, which by the way is a project that I already have on my channel, but now I'm making a bigger one with a lot of improvements. So first let me show you this tank here, and as you can see this is messed up because it is broken, it once fell on the floor and so on. But let me just show you how this works and what will be the future update of this project, and also a little bit the board that is using. This is the PCB that is controlling this tank, and as you can see it's based on the Arduino. It has an H-bridge to control 2 DC motors. It has a DF player, and with DF player we can play sounds from an SD card, so I can place the MP3s on this DF player and play sounds for the motor, when I start the motor, when I shoot fire, so when I make a fire with my smartphone or the radio controller, I can make the sounds of the tracks and so on, so make the tank a little bit more realistic. I also have an H-bridge, and this H-bridge will control 2 DC motors, and those DC motors will move the tracks. We have a power MOSFET in case that you want to add some fires or maybe laser or a light. And we also have two DC to DC buck converters in order to get 12 volts and 5 volts, 5 volts for the Arduino and 3.3 volts for the NRF24 radio module. So this PCB will use some lithium-ion batteries. In this case we only have two, but I'm pretty sure that for the bigger tank I will use a bigger pack because it will have a lot more power, and I'm pretty sure that I will change the PCB as well. First of all, because it will have to handle more power, so we probably need a bigger or a better H-bridge, and also because this tank I think that it will work with some brushless motors instead of DC motors, so maybe we won't use an H-bridge but an ESC. Anyway, let's take a look at the PCB. Of course, it's based on the Arduino, so we have an Arduino Nano to control everything. This will receive signal from these pins, which are the NRF24 radio module, or maybe these pins, which is the Bluetooth module. So depending on what you want to control this with, you can add one module or the other one. We have two buck converters. These are for 5 volts for the Arduino and the rest of the logic parts. And this is for 3.3 volts just for the NRF24 radio module because it needs a steady 3.3 and a lot of current. And then we have the DF player to play the sounds with an SD card. And here we connect the speaker at these wires here. We have a MOSFET to control any load that we want, maybe just a wire that will heat up and control a rocket, maybe lights, maybe laser, anything that you want. And here on top, as you can see, we have a bunch of pins, and these are for servo control. So we can connect a bunch of servos here to control maybe the turret, maybe the gun, and maybe anything that it will move on top of the tank. I'm not sure yet because the details, I'm not working on the details yet. Let me first show you side by side the new update version and the other tank, the previous version, in order for you to see the size, and you'll see that this is quite big. Okay guys, so this is just the base of the new version, and by base I mean this part here that you will see in the middle. So we still need the tracks, so the wheels, all the wheels and the tracks, and also the upper part, which will be the skirt and this top part and the turret. And by the way, I don't even have the turret yet because I'm still designing this, because I want to add a lot of controls inside, so it would make a 360 spin, control the angle of the gun, and so on. So as you can see, only this part here, the middle one, is this one. So it's quite big, it can almost fit on my workshop table. So guys, in order to print this, as you can see, I had to divide it in parts that will be less than 300 by 300 because that is the maximum size of my 3D printers. And also I had to make some parts so I can screw this together. As you can see, this one here. These two are screwed together with some screws, two here and one here. This shaft here is the one that will spin the gear wheel, and that gear will apply the force to the entire track. And here we'll place the motors. This, I think it will be brushless motor connected with a pulley to this gear, so we have more force. And I'm also using some bearings for support. Okay, so then we have these parts here, and these are some details, and also the skirt. As you can see, this part is the updated part for this part here. We have another gun exit. This will be the gunner place. This will be the driver place. Then we have the skirt. This will be on top, so this will be this kind of details here. I'm not sure how to call this. We have more parts here, and of course the tracks. And as you can see, I have hundreds of tracks here, and in order to merge this together, I will use some 1.75 filament. So just melt the point, and that will be a joint together track. So as you can see, maybe I will even need to print even more because we need a lot of tracks. And here are all the wheels. This is the back wheel. I don't have the gear wheel yet, and this will be a normal wheel. So as you can see, we have like, I think already we have like 2 or 3 kilograms of PLA, and soon we will have even more. And this part is very interesting because now the new version will have suspension as well. Okay guys, so the old tank doesn't have suspension, but with a tank this size you will need suspension, so I will add this kind of wheel, and this will pass through these holes as you can see here, and it will be able to move up and down inside of the tank. And inside of the tank I will use those parts that I show you, these kind of parts. This will have a bearing here, and here on this tip I will add some sort of spring, and that will apply force on the wheel. So that will be here inside, and it will move, and at the same time it will move this wheel, and by that we'll have suspension. So that is one of the improvements that I have for this tank. For now guys, I can't show you any other update because I don't have the turret, which will be the part that most updates will have because it will move a lot better. But as you can see, we now have suspension. We now have the parts divided into smaller parts, so we could print it on the printer, which is 300 by 300. We also have the tracks and the wheels, and we have some more details on the parts to make it look better. And of course at the end I will paint it all maybe gray or maybe a beige color. I'm not sure how that color is called, beige. Anyway, maybe even military with some camouflage. So I will give it a better look. But for now, this is what I have. First of all, I'm using brushless motors with a shaft connected to the gear wheel, so we'll have more force. Then I'm using parts that we'll have to screw together because this will be quite big. The detail parts and the skirt is the same, and the turret and the gun will be different. And then I'm not sure what more details I will add, maybe more servos, maybe I really want to add smoke inside, and maybe a laser. And maybe also an FPV camera inside, so you can use this with the goggles and also with the radio controller. Okay, so that was the update for a future project, which is the 3D printed tank. And this will be the second version, a lot bigger. Anyway, now we can go with the next part of this video, and that will be to show you a new product that I have here in my workshop, and that will be another Keysight power supply. This will be very powerful, but also quite pricey. So anyway, I hope that you will like it. So let's see that, and after that we'll make the Q&A where I'll answer the questions from the past week. So let's get with the product. Guys, another thing that you should know about me is that I have two cats. This one here is Yoko, and she is Persian and is fully black, and the other one is called Yoko and is fully white. So these two together are like yin yang. So I had this cat for like 9 or 10 years and it's part of the family, and she's also helping me with my projects, and usually what she does is steal my components and play with those in the house and lose them. Okay, so now let's go with the next part, which is talk about this new product, which is a power supply from Keysight. So this is the beauty, guys. This is from Keysight. This is the E36313A power supply. This can deliver up to 100 watts, I think. It has a toroidal transformer inside. I won't open it again because I already opened it once because I blew the fuse, and that's because this was set for 115 volts for US, and I didn't look at that, so I plugged in 230 volts for Europe and the fuse blew away. So I had to open it and change the fuse because it was an internal fuse. Anyway, so let's just power it up. So it has a lot of modes. It has 3 outputs, so 3 channels. Each output can deliver up to 25 volts and 2.5 amps, I think. But then we have some settings for the output. So we have some modes. First of all, we go in the operation mode. The first mode is independent mode. So we have each independent output, these 25 volts and 2 amps, this 25 volts and 2 amps, and this 25 volts and 2 amps. But then we go into series mode. Let me just... Okay, so first let's go into normal mode so you could see. Each one has 25 volts output and 2 amps, but in series mode it will put 2 outputs in series, so we have up to 50 volts but also 2 amps, because in series we can double the voltage, but in parallel we can stay at the same voltage but we double the current. So we go into parallel mode. So in parallel operation the output 2 will have 25 volts, but now we have 4 amps. So in this way we'll have here on the output, on the green output, we will have up to 4 amps and 50 volts. So that's how you use it in series and also in parallel. We, of course, using the keyboard, we can set the voltage and the current values. We have the knobs here. If you want to set it even more precisely, we can set on each output we enable the second one, the third one. And on the main menu, we have output 1, 2, and 3. And with this button, we select on which output I want to change the voltage, or if I want to change the current value. And then I can set to the other one and the other one, and if I press on, this will be enabled. If I press on, this will be enabled, and if I press on, this will be enabled. And when you are into parallel mode, only the green one will be the output, and in series mode I think is the first one or also the second one, I don't remember. So this is the power supply. This is a little bit expensive. I think it's more than 600 euros, sorry, but it's a good supply. It's very, very heavy. I think it weighs like 10 or 11 kilograms. And remember, we have a toroidal transformer inside for more efficiency. I will leave a link below if you want to see all the efficiency for the power supply and the circuit inside and more, because I don't really want to open it once again, because it's like half an hour of taking out screws and then the PCB and so on. So this is my new beauty for my workshop. By the way, I haven't bought this because I don't have that amount of money right now, and also I don't really need this a power supply this powerful. But Keysight give this to me as a gift for some videos that I made for Keysight, so I'll try to use it even more and maybe find a project that is suitable for this supply, maybe test the efficiency, or maybe connect it to something that really needs a very stable output and also a lot of power, because at 15 volts and 4 amps we have 100 watts. Okay guys, so here we are another day, and the last part for this video is the Q&A. So I'll answer the questions from the previous video, from the last weekly update, or ElectroNews, maybe I'll call it like that. And we had a lot of comments, but not all of those were questions, and I selected a few of these because I don't want to make this video too long because it will be boring. That's why I'm making a weekly update, because in this way I can answer just a few questions and not make the video too long. Okay, so the first question is from Aaron Steen, and it goes like this. Hey, I'm a first year engineering student. I have been taught a complete course on electromagnetism and electronics, but I don't fully grasp the concept of the inductors yet. Could you recommend a cool beginner project which utilizes this component? I tend to learn a lot by focusing on a project. And you do very good to do that, because that's why I do as well, because anytime that I start a new project, I will learn something new. It doesn't matter if it's easy or hard, I usually learn something new, because when you have a problem and you have to fix that, that's when you learn a lot. So I selected a few projects that I have on my YouTube channel that I recommend you to watch and maybe even try, and with this I will assure you that you will learn a bit more about inductors. So the first project, of course, it will be the inductor meter with Arduino, because in order to know how to measure inductance, you first have to know how the inductors work in order to measure it. So you'll see how we store the energy in the inductor, how to make it resonate, how to calculate the frequency, and then use a lot of formulas to get the inductance value. And then I recommend you the second project, which is the buck or the boost converter, because this project are using the inductors, and in those videos I explain how the inductors work to boost the voltage, how it stores the energy in the magnetic field, how it collapses, how it regulates the current value, and so on. So watch these two videos. And I also recommend you to search for the project that is called Joule Thief, because this is a very simple circuit in order to store the energy using an inductor, and that will teach you even more about inductors. Okay, so now let's go to the next question. This one is from Just Woodwork, and it goes like this. Nice idea and nice video as always. But the question for the Q&A is, what ICs do you think an electronics beginner should have? I mean, like 555 timers and 80 tinies. Okay, so I've selected just a few because there are a lot of ICs. First of all, the 80 tiny, I know it's an IC, I mean it's an integrated circuit, but it's just a microcontroller. So if you include that category as well, there are a lot of microcontrollers. You could have Arduino, PICs, ESPs, and so on. So for me, 80 tiny is not just a normal IC. So I just selected a few ones. So for sure you will need an op-amp or operational amplifier, because in any circuit you could use that. You use it to amplify, to compare signals, to follow signals. So you will also need comparators. You could use an op-amp to make a comparator, but it's better to use just a dedicated IC for that. It is called a comparator. So for sure you will need operational amplifiers, and in my case I have a bunch of LM324 that I use every day. Then you will need a lot of MOSFET drivers, because when you work with electronics you will use those MOSFETs a lot, but usually you will use the MOSFETs at a higher voltage, higher frequencies, and directly a signal from a microcontroller won't be enough, because usually it's 5 volts, and at high frequencies the gate might not be activated, fully activated. So that's why we use the MOSFET drivers. You could use a BJT as a driver at the gate of the MOSFET, but it's not as good as a dedicated IC for a MOSFET. Then you will need some Schmitt triggers to compare signals and detect when it passes a certain value. Of course, the 555 timer, and a lot of other small components like this. And as I told you, the 80 tiny is just a microcontroller which could do a lot of stuff. Okay, so now let's go to the next question. We have a few more. What video software are you using for editing your motion tracking text? Okay, so I will answer this question, but also I'll take advantage of this question and answer a few more, because a lot of you guys are asking me for all the softwares that I'm using in different questions. So that's why I'll now tell you all the software that I usually use for my work. First of all, to make that motion tracking for the text and all the effects in my videos, for editing my videos I'm using Adobe After Effects. And with this program I make those tracking, I make the color correction, adjusting the image. You could even use the back green screen if you want. You can make any effect that you want, even 3Ds, work in 3D if you want. Okay, so for the next software I use Audition to record my voice, the scripts. So I'm editing the sound with Audition and with my microphone. To edit the 3D parts I'm using Blender, and to make the animations I'm also using Blender together with Photoshop for making all the text and the graphics. Then to repair the 3D parts I'm using NetFab, and to print the 3D parts I'm using Repetier to make the slicing and the G-code. For the circuits and the PCBs I'm using now EasyEDA. I was using this Design Spark a few years ago, but now I'm using EasyEDA for both the schematic and the PCB. Of course, for the Arduino, I'm using Arduino IDE. I know that there are other softwares there, but I'm using Arduino IDE. For programming in Verilog, I'm using Quartus and Model Sim. And for making my websites, which by the way, I'm using HTML and PHP to make that. And to code that, I'm using Dreamweaver, which also is from Adobe. And to make the local server, I'm using XAMPP as a server. And for editing my scripts, Word, and for calculations and graphs, Excel. So these are basically the softwares that I use almost every day. Okay, the next question is from Aditya Gautam. Okay, so then the question goes like this. What's in the box named time travel stuff? This box here, a black hole. Okay, so the next question is from Breck Toms. I'm developing a brushless motor controller for a hub motor of 48 volts. So by what time you will get that video? Will we get the video about it? Okay, so I've talked about this controller maybe a few months ago in a video. This will be the same ESC as my open source ESC, but with a voltage boost at up to 48 volts. So it's not that easy to boost this voltage. So I'm not sure when I'll release that video. I already have a PCB that should arrive soon from GLC PCB. But you see, if I fail anything on that PCB, I'll have to make a second version. So I'm not sure when I will have that project yet, because boosting the voltage for 48 volts, I had to change a lot of the circuit because the drivers and the MOSFETs were only for 24 volts, so now for 48 it's a lot more difficult. The voltage regulation as well will be more difficult. The tracks of the PCB have to be a lot more thicker and so on. So maybe next month we'll have that project, but if I have to make a second or a third version, I'm not sure when I will release that video. Maybe I will release a first part with the project on the breadboard and then the final PCB. So guys, these were some of the questions that I had on my video. By the way, all the comments were positive, so thank you very much. I think that there was no negative comment on the video, so I guess that you will like this kind of video. I hope that you will enjoy the future updates. Actually, I think that I will call this kind of videos ElectroNews because somebody recommended that name and I think it's great. So thank you very much. Enjoy this and see you in the next video. Keep up, you guys. Oh, and by the way, remember to comment below for the next video. And if you can place something like question for the Q&A, it will be a lot easier because usually we have a lot of comments and I'm not sure which one is just a comment or just a question. So in order to make the difference, just place below in the comment for the Q&A and your question. So thank you very much. Now, see you later, guys.